Hello everyone. It has been a long time since I uploaded the last video. So today I'm going to talk about additional math. Let's take a look at 2023 major paper, variant 1, 2. Okay. Um, First, this diagram shows the graph of y equals to a cosine bx plus c. Find the values of constant a, b, c. Okay, A represents the amplitude. To measure the amplitude, we find the middle lines. The middle between 2 and -6. The difference between them is 8. So half is 4, right? So 2 minus 4 is -2. 1, 2, 3, 4, -2. Okay, so this would be the middle line, right? We know that both sine cosine, they have the middle line, they're oscillating, right? Up and down, pass through this middle line. So amplitude is the distance from the middle line to the maximum or to the minimum, right? To the peak. Okay, normally we take it to the peak. So it would be, right? It would be right, it would be 4, right? It would be 4. Okay, so A is 4. Okay, and C is the movement of the middle line, right, from y equals to 0. Originally, for any function y equals to cosine x or sine x, the middle line is y equals to 0, right? This is the middle line. Okay, so now the middle line is -2, so C is -2, right? B is something relevant to the period. Okay, the period. We know that the original period of 360 over B, right? Original period divided by B, we should get the new period. The new period here is from -480 to 480. Here, from this point to this point, we have one period. So the new one period, right? One new period is 480 times 2, 960. Okay, so B would be 360 divided by 960. Okay, now divided by, I guess the common factor would be 120. Divided by 120 is 3. Divided by 120 is 8. Okay, we need to realize that from this point to this point, right, this is one entire complete period, right? One complete period. Okay, so the original period, right, divided by B, we should get the new period. So B is 3/8. Solve the equations. This given this, and giving your answer in the form of A plus B sub 5, where A and B are integers. So let's make them into ax squared plus bx plus c form. Okay, ax squared plus bx plus c form. This would be our A. This would be our B, including the negative sign. This would be our C. Okay. The reason why we include the negative sign, this is because the original equation is in addition. This is addition, right? So this minus 4x can be written as plus -4x. So plus, right? Plus is still plus, so the B is -4. In short, right, we need to consider the negative, right? Consider the sign. Okay, so x by the quadratic formula is -b plus minus square root b squared minus 4 times A times C times C divided by 2 times A. So this would be 4 plus minus 16. This is 4 times 3. We have 12. A plus B times A minus B. It is A squared minus B squared, right? A plus B times A minus B. It is A squared minus B squared. So it would be A squared. A is 2. 2 squared is 4. 2 squared is 4. 5 squared is 5. Divided by 2 times. Now normally this thing we don't multiply, we don't expand it, because most of the time it could be cancelled off later, right? After a few steps, cancel with the common factor 2 top and the bottom. So let's see. This is -1. -1 times -1 is positive 12, so it's 28. Square root 28 would be 4. Square root 4 times 7 is 2. Square root 7 divided by. Now, yes, right? We could see that on top has a common factor 2. Cancel with the factor below. Alright, so let's see. Minus A plus B squared. Oh, I made a mistake. This should be minus. It should be minus, right? I moved this term to another side. Minus. So it should be -3. Should be positive. So it is 16 minus 12 should be 4. Right? Should be 4. Square root 4 should be 2. Okay. Yeah. Should be 2, so it would be 4 plus 2, 6. 6 divided by 2 is 3 over 2 square root 5, or 4 minus 2, 2 divided by 2 is 1 over 2 plus square root 5. And then this is the form required by the questions, which means that we need to rationalize our denominator by multiplying the conjugate of the denominator, top and the bottom, right? At the top and the bottom. This would be 1, 2 minus Z5, and then 2 plus Z5 times 2 minus Z5. So this would be 6 minus 3 Z5. This is A plus B times A minus B, A squared minus B squared. And this would be 2 minus Z5. This would be A squared minus B squared. So below is negative, divided or multiplied by negative. For two-term polynomial, the order will change, right? Order will change. We have a minus b with times a negative, it becomes b minus a. A minus b divided by negative, it still becomes b minus a, right? So the order will change when you have two terms, right? Two terms polynomial, the times that divide negative a and b will swap with each other, right? So this would be 3 Z5 minus 6. This would be Z5 minus 2. Okay, they are required to put the Z5 on the second term for the second term. So maybe just move the term, right? But I guess this doesn't matter. But just for safe, right? Okay, so that's all for these questions. 2 Z5 negative 6. Yeah, negative 3, 6, 5. Okay, the diagram shows the graph of y equals to modulus fx, where fx is a cubic polynomial found in factorized form. We know that this cubic has 3, right? Has 3 roots. So the root -2 probably comes from x plus 2, right? If you have been doing factorization and solve quadratics or any equations by using factorization, we should know, right? Normally the roots -2 come from x plus 2. The roots -1 come from, the root +1 come from x minus 1. The root +4 come from x minus 4. Now, here in front should have a coefficient k, because no matter what this value of k, if you don't write the k here, means by default is 1. But now it's not necessarily 1, right? It should be k, because this number, it won't affect the x-intercept, right? If you are familiar with the transformation of graph that we learned in trigonometry, right? It has this thing, right? The effect, right, of this A is to vertical stretch, right? It's a vertical stretch. Okay, so which means that the k here will also just vertical stretch this graph, right? This graph, the original graph, the graph without the k. But vertical stretch, as we know, right, vertical stretch, it won't change the x-intercept. Okay, but this k, right, since it's stretched vertically, it decides the y-intercept. Okay, so in order to find this k, we can use the find y-intercept to find this k, right? This is fx. Okay, now the entire graph is above the x-axis. This is because of the graph is after being applied modulus. So this means, right, this is the point 0, 24. This point means that, right, when x is 0, f0 modulus, we should get 24, right? So we should get 24. So 24 should equals to modulus f0. Okay, so modulus, substitute 0 inside. 0 plus 2 is 2, 0 minus 1 is -1, 0 minus 4 is -4. So what we have here is 8k will equals to 24. So 8k will equals to plus minus 24. So k will equals to plus minus 3. Okay, so that means, right, fx. So we have two possible expressions. Okay, plus minus x plus 2, x minus 1, x minus 4. Right? Solve the inequalities. Probably when you see both sides, there are modulus on both sides. The easiest way is to square both sides, right? Is to square both sides. After you square this, the modulus gone, right? So a minus b squared is a squared minus 2 times a times b, which is 20x, okay, plus b squared, 4, a squared, plus 2 times a times b, 8x, plus b squared, 1. Okay, put all the terms to left hand side so that the another side would be 0. So this is square. We have 9x squared minus 28x plus 3 less than equals to 0. So yeah, we can factorize this. 9x times x, 3, 1, negative 27, negative 1. Okay, so total we have negative 28. So to solve inequalities, now I need to sketch this graph, right? This is a quadratics, right? This is a quadratics. So in the factorized form means that this factorized form tells us that one root would be positive 3, one root would be 1 over 9, right? Positive 3, this is x-axis, okay? Now, this is the graph of these functions, right? Now, this equation, this inequalities, solving these inequalities is asking us for what region, what interval of x, for any value in that interval, right? You substitute in the output, right? The output, which is the y, right? If you let this function to be y less than or equal to 0, then you look at this graph, right? For which region, every point, the y coordinate of every point is equal 0 or less than 0. Here, right? In this region, every point has non-positive, including these 2 points, right? Has non-positive y coordinate, right? Means that there, right, the corresponding feasible region for this inequality to hold is x greater than or equals to 1 over 9 less than or equals to 3. Okay, that's all for this questions. In these questions, all lengths are in centimeters and all angles are in radian. The diagram shows a circle with center O and radius r, point A and B lines of circumference. Okay, the length of the minor arc is 12, so which means that what does this word minor mean, right? Because if I just tell you arc A and B, if I just tell you arc AB without the word minor of major in front, it could be like this, which is the major arc, right? From A to B, it could be going this way, or it could be going this way, right? It could be going this way, which is the minor arc, right? So this is what the minor means. So the minor arc here is 12. Length, the area of the minor sector AOB, this area, right, is 57.6 cm square. This area, right? Okay, so the point C lies on tangent, okay, to the circle at A, such that OBC is a straight line. Find the value of R and theta. So we know that arc length L, right, arc length L equals to 12. Okay, and L, we have the formula, arc length is R times theta equals to 12. And then we know the area of the minor sector is 57.6. Area is 1/2 R squared theta is 57.6. Yeah, so R squared theta times 2 on both sides, this would be 115.2. Okay, times 2, 115.2, and then let's name these first equation, second equations, right? Solving simultaneous equations. The fastest way of this is divide, right? You divide second equation by the first equations. So R squared theta divided by R theta equals to 115.2 divided by 12. So theta cancel, R cancel. R would equals to 115 divided by 12. 115 divided by 12. What is this? 15.2 divided by 12. Not times 12, divided by 12. So it's 9.6, right? It's 9.6. Beautiful number. Okay, then theta, right? From the first equation, we know that theta would be 12 divided by R, which is 9.6. 2.4, right? This differ by 2.4, and 9.6 is also multiple of 2.4, so this is 5 over 4, right? 5 over 4, which is 1.2, right? 1.2. Okay, so maybe fractions 1.2, right? Just double check, right? So let's see. 12 divided by 9.6, yeah, 1.25. Oh yeah, correct. 5 is not 1.2, 1.25, yeah. It's 5 over 4, but instead it is 1.25. Yeah, 1.25, okay. Find the area of the shaded region. Give your answer to correct to one decimal place. shaded regions. Now there is no direct way to find this, so we need to go indirectly. Go in an indirect way, so we need to use the area of this triangle minus the area of this sector. So area, we know that, right? We learned from IG mathematics, right? We know that tangents and radius, they are 90 degree, right? They are 90 degree. So in order to find the area of OAC triangle, we just need to take this as base, take this as height, base times height divided by 2, right? Then we are done. Now the question comes, right? What is the base? What is the height? The height here probably is, obviously, is R, which is 1.25, oh no, it's 9.6. Okay, theta is 1.25. We have angle, we have one side length inside a right angle triangle. Then obviously we can use tangent, right? Tangent. Okay, so in triangle OAC, tangent theta, which is 1.25, would equal to opposite, which is AC, divided by adjacent, which is 9.6. So AC would be 9.6 times tangent 1.25. But be careful, this 1.25 is in radian. So when you use your calculator to calculate this thing, make sure your calculator setting is in radian. 9.6 times tangent 1.25. So which is 28.89. Okay, so area of shaded region would be 1/2 times base, 1/2 times base times height, which is the radius, 9.6, minus the area of the minor sector, which is given by the questions, 57.6. Okay, so this would be answer times 9.6 divided by 2 minus 57.6. So this would be 81.08, right? Give your answer correct to 1 decimal place, so 81.1 cm squared. Okay, I guess that's all for these questions. Find the exact solutions of these equations. Now, these kind of questions, probably most of the time we need to observe, right? Observe. The most common this kind of question is something like this, right? They will directly give you something like this, okay? Right, then this is if you let y equals to p to the power of 1/3, then this will be 6y squared minus 5 minus 13p, which is a quadratic. Just solve it. But now this is, now they are not giving you in this way, but giving in this way. All right, actually from this to this is just one more step further, right? One more step further. Okay, we just need to because it's negative, right? We just need to multiply both sides by p to the power of 1/3. We are done. Then you get this thing, right? Because multiplying the same base by law of indices, we are adding the power, right? Okay, and then this multiply this, right? Adding the power is 0, p to the power of 0 is 1, so there's no p, right? 5 means 5p is 0, but p is 0, no need to write, power of 0, because p to the power of 0 is 1, right? And this time this is this, right? So yeah, this is just one more step further from the most common kind of question that you will see in some other partial paper, some earlier partial paper. Okay, so p to the power of 1/3, 6p, 1/3 minus 5p, 13 equals to 0, p to the power of 1/3. 0 times anything is still 0. So 6p, multiplying the same base, we add the power. 1/3 plus 1/3, 2/3. 5, 13p, 1/3 equals 0. Okay, now the most common way of doing is let this thing to be y, and then just solve it and then change the y back to p and solve. But I personally think that would be a bit troublesome, right? I would prefer directly factorize. Okay, 6 and 5, 2 and 3 and 5, 15 and 2, we get 13. Okay, so 2p 1/3 times 3p 1/3. Okay, and then we have a 5, 1, so negative 15 plus 2. Yes, so we have p 1/3 equals to 5 over 2, but or p 1/3 equals to negative 1 over 3. Obviously this is no solutions or no real solutions, right, to be precise, but because we know the exponential function, if you record the graph of any exponential functions, okay, as long as the base, oh no, this has solution, sorry, this is solution. The base is not fixed, right? This has solutions. If the base is positive, then it cannot be negative, right? But now the base can be negative, obviously, right? So we raise to the power of 3 on both sides. Because why we raise the power 3? Because now our target is to find p. P means p to the power of 1, right? How do we change the power from 1/3 to 1? Raise, right? You times 3. 1/3 times what is 1 times 3. How do we multiply power? When we have power of power, right? So we raise power 3 on both sides. So it would be 1, 2, 5, 8. P will be power 3. Odd power negative is still negative. This is 27. Okay. Exact solution, so leave your answer in fractions. Solve the equations. I'm giving your answer in exact form. Okay. Now, if you want to solve, you need to combine these two log into a single log. But before that, make sure the coefficient of logarithm is 1. So we have square, sorry, x plus 2 equals to 1. So now we successfully make sure the coefficient of both log is 1 now. Only now, right? We can combine them into single log. At the first step, you cannot combine them, okay? Because this is not 1, right? This is not 1. So minus means divide, right? 2x plus 5 square divided by x plus 2 equals to 1, right? Equals to 1 means that the base and the argument are the same. There's no base means by default it is 10, right? So which means that 2x plus 5 square over x plus 2 should equals 10. Okay, so 2x plus 5 square would be expanded. A plus b square is a square plus 2 times a times b plus b square equals to multiply this to another side, so it would be x plus 2. Rearrange. Can we factorize this thing? 23 equals to k. Did I make any mistake? 2x plus 5, yeah, divide x plus 2 equals to okay, should be log 10, it should be, yeah, oh wait, it's 10, right? Just now I read it, I mentioned 10 because it cannot be factorized. Sometimes it can be factorized. It could be actually, it is indeed cannot be factorized, or sometimes, most of the time, because of my own careless mistake, right? is 10, x plus 2 times 10 is 10x plus 20. So it would be plus 10x plus 5 equals 0. Or 5, seems like still cannot be factorized. Double check. Yeah, I copied the question correctly. Correct first step. Second step correct. Third step correct. Fourth step correct. Yeah, then it should be correct. Okay. So if we cannot factorize it, just use the binomial, not binomial, quadratic formula, negative b plus minus square root b squared minus 4 times a times c divided by 2a. So 100 minus 16 times 5, 80. 100 minus 80, 20. Square root 20 is 2 sub 5, right? It's 2 sub 5. So you take the 2 and here we have factor 2 cancel. So we have negative 5 plus sub 5 divided by 4. Okay. Now we need to double check whether both answers are acceptable or not, because for log questions we need to be careful, right? The argument of log must be greater than 0, right? Must be greater than 0. So we know that negative 5 minus sub 5 divided by 4, what is this? So double check with our calculator, right? Negative 5 minus sub 5, okay, and answer divided by 4 is negative 1.8 something. So negative 1.8 something plus 2, yes, is positive. Negative 1.8 something times 2, negative 3.6 something, 2% plus 5, yes, positive, yeah. So the negative answer could be accepted. Okay, so yeah. Given that cotangent square theta equals to 1 over y plus 2, second square, second theta is x minus 4. Now find y in terms of x, means that now we have x, y, and theta. Now the question is asking for y and x only. So which means that we need to get rid of the theta, right? By replacing them, one of them, by using some trigonometry identities. So cotangent and secant, they don't have direct connection trigonometry, but secant square and tangent square has connection, right? So from here we know that cotangent square, right, when I transform it to tangent square, we are taking reciprocal, right? So reciprocal of this is y plus 2, and then secant square, right, is x minus 4, the entire thing square. Okay, because secant square is entire thing, so you square secant is you square this entire thing, x minus 4. So, and then yeah, these two have connection. We know that 1 plus tangent square theta equals to secant square theta. So 1 plus tangent square, okay, equals to secant square theta, right? So y would equals to x minus 4 square minus 3. Okay, so yeah, I guess this would be accepted. Solve the equations. Set 3 coseconds 2 phi plus 3 pi over 4 equals to 2 for yeah, the domains of the phi must be given, otherwise we have infinitely many solutions, right? Because we know that sine, cosine, tangent, all these trigonometric curves can be extend, yeah, because equals to 2 means that I'm drawing a horizontal line, y equals to 2, right? And drawing this graph, it could be right, it could be a lot of, it could be a lot of intersection, right? Infinite intersection if we don't restrict the domain. Okay, so this is a must, right? Giving your answer in terms of pi. Okay, So cosecant 2 phi plus 3 pi over 4 equals to 2 over square root 3. Now cosecant, our calculator don't have the inverse function. We don't have cosecant this function on our calculator. So we change it, right? Reciprocal cosecant is sine 2 phi. Now we take reciprocal on left side, so we also take the reciprocal on right side. Okay, so square root 3 over 2, it is a sine ratio for a perfect angle. This is 60, right? A perfect angle. Okay, a special angle 60. All right, so this, which means that the reference angle, right? Now this, if you sine inverse square root 3 over 2, this is not a solution. It's not necessarily a solution. Okay, this is just a reference angle. All right, so you cannot name this as this, right? Strictly speaking, if you write something like this, 2 phi plus 3 pi over 4, right? This is wrong, right? This is wrong. I mean, it's partially correct, right? Partially is, because this angle need not to be necessarily 60 degree, right? It can be 120, right? Because sine inverse functions, right? Sine inverse function is a 1-to-1 function, but sine functions is a many-to-1 function. So harshly speaking, right? The writing should be a bit careful, right? Okay, so alpha, right? So this is alpha. Okay, first and second quadrants, the sign is positive. Okay, so which means that this is, now in radian system pi over 3, right? Pi is 180. 180 divided by 360, yes? Sine 60 squared 3 over 2. Okay, so within negative pi to pi, it would be, which means that now we need to find out the region of this thing, right? So 2 phi times 2 times 2 times 2, 2 phi is greater than negative 2 pi, less than 2 pi, plus 3 over 4, so 2 pi plus 3 over 4, 3 pi over 4, 2 pi plus 3 pi over 4, it would be 811 pi over 4, and then this would be plus negative 8 plus 3, negative 5 pi over 4. Okay, so at most I can go 45 degree, pi over 4 more, right? Pi over 4 more. This is pi over 6. Pi over 6 is less than pi over 4. So yes, we can go in this way, right? For this angle. So 2 phi plus 3 pi over 4 would be negative pi minus pi over, oh no, this is pi over 3. Pi over 3 is greater than pi over 4. Pi over 3 is greater than pi over 4. No, cannot. I thought it's pi over 6, pi over 3, cannot. So the only answer that we can do is pi over 3, 2 pi, pi minus pi over 3. Pi minus pi over 3, which is 2 pi over 3. Okay, and then this is what? This is more than 2 pi. More than 2 pi, so this line have a second representation, which is 2 pi plus pi over 3, so which is 2 pi, so 7 pi over 3. Right, 7 pi over 3, and then plus a 2 pi, 6, 8, 8. No, wait. This is, how much is this thing? Pi over 4. Pi over 4 is 45 times 11, 495 minus 360, so it's 135. At most can go 135. This is 60. So 120. Yeah, so we could have one more answer for this thing, which is plus one more round. One more round is 2 pi, 6 pi, 8 pi, right? 8 pi. 60, 480. Yeah, correct. Okay, so 2 5 equals to minus 3 pi over 4, so this would be 12. 4 pi minus 9 pi. 4 pi minus 9 pi would be negative 5 pi. This would be 12. 8 pi minus 9 pi, negative pi. This would be 12. 28 pi minus 9 pi. 28 minus 9. 28 minus 9 is 19 pi. This is 12 pi. 12 times 32 minus 9. 32 minus 1 is 21 pi. So 5 would equals to, divided by 2 is 24. 2 is 24. 2 is 24. 2 is 24. Okay. So yeah, I guess no, 32 minus 9 should be 23. 23, not 21. 23. Yes, 23. Okay, so yeah, that's all for this thing. These questions. Find the number of ways in which 14 people can be put into 4 groups containing 2, 3, 4, and 5 people. Okay, the order does not matter as long as it's the same group of people. The order of the people in the group doesn't matter. So we use C, right? When order does not matter, we use C. 14 C2, and then we have remaining 12 C3. Then we have remaining 9 C4, and then remaining 5 C5. But actually, last term you don't need to write it because 5 C5 is 1. You times 1, no change. But if you want to write it, doesn't matter. So 14 C2. 14 C2 times 12 C3 times 9 C4 times 1. So 2, 5, 2, 2, 5, 2, 0. 2, 5, 2, 2, 5, 2, 0. Okay. 6-digit numbers are to be formed using digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each digit may be used only once in any 6-digit number. Must not start with, okay, 0. How many digits? No further restriction. So we have 1, 2, 3, 4, 5, 6. Cannot 0, right, for the first digit. This is the first digit, we have 9 options, right? We have 9 options. And then 9 choose 1, right? Times up. And then let's say out of this 1 to 9, I choose 1. Let's say I choose 7, right? We left with not 8, it is 9, okay, including 0, right? So 9, the order doesn't matter, different order is different number, right? I arrange 1, 2, 3 in this way, and in this way, this is 100 something, this is 300 something, right? The order is different, the number is different. Okay, so it's 9p5. Okay, 9c1 times -p5, so 9c1 is 9, right? 9 times 9p5, so it is 136080. The 6-digit numbers is divisible by 10. Divisible by 10. Then think about what kind of number divisible by 10. Think about divisible by 10 means multiple of 10, right? It must contain the factor 10. In other words, it must be multiple of 10. Multiple of 10 is 10, 20, 30, 40, 50. We can see that, right? The last digit must end with 0, right? The last digit must be 0. Okay, so last digit must be 0. 1, 2, 3, 4, 5, 6, 0. So no any other options, must be 0. So the remaining 9, I P, right? P the first 5 digits, right? P the first 5 digits. So it's 15120. 6 digit number that's greater than 500,000 and even. 1 2 3 4 5 6. We have 6 digit number. Greater than 500,000 means that the first digit needs to start with either 5 or 6 or 7 or 8 or 9. And even means that the last one should be 0 2 4 6 8, right? Last digit is even, the entire number is even. Okay, now do we have any number clash, first digit and last digit? They do clash, right? 6 and 8, they clash. So we need to separate into 2 cases, right? Case 1, okay, you are using the last digit or first digit as the divisor of case. Doesn't matter, I use last digit. Last digit to be 6 or 8, okay. Then I would have 1 2 3 4 5 6. So we have 6 or 8, we have 2 options, right? So it's 2, choose 1, okay. After I choose 6 or 8, one of them, then here I only left with 4 options, right? For example, let's say I choose 6, I left with 5 7 8 9, this 4, right? For example, or maybe I choose 8, I left with 5 6 7 9, this 4, right? So when you clash, right, your choices here will affect the choices here, right? So this is 4, choose 1. Okay, we have been choosing 2. We have chosen 2, right? We have chosen 2. So the remaining 4 middle number chosen from 10. 10 minus 2, we have chosen 2. So we have 8 available for us to choose for remaining middle 4, right? Oh, it must be P, okay? The order doesn't matter. Here you write C or P, doesn't matter when it is 1, okay? It's 1, there's no such thing so-called order, right? Order only exists for number of items more than 1, okay? So you can do experiments, right? You key in your calculator 2P1 and 2C1 is the same. 3P1 and 3C1 is the same, right? Okay, so this would be 4 times 2 times 8P4. So 13440. This is the first case. Second case is the case where the first and last digit do not clash. So last digit is 0 or 2, right? 0 or 2 or 4. So we have 3, choose 1, right? 1 2 3 4 5 6. Last digit is 3, choose 1, right? So 3, choose 1, and then now the last digit doesn't affect my first digit available options because they do not clash. First digit would be 5. 5, choose 1. We have chosen 2, so we have 8 remaining. Out of 8 remaining, we choose the middle 4, right? So it's 5 times 3 times 8 P4. Now the middle one should be P, okay? Order does matter. 5 times 3 times 8 P4. So it's 25200. So add them up. 13440 plus 25200. 04683. 38640, right? 38640. Okay, yeah, 38640. So for this question, given that f(x) equals 2 ln 3x minus 4 for x greater than a, find the least possible value of a. For this function to be defined, the argument must be positive. So x greater than 4 over 3, right? So the least value of a would be 4 over 3. Okay, write down the range for ln functions, if you sketch the graph of the ln function, right, consider the graph. Normally when they ask for range, you consider graph, right? Range is the y, right? The y value. Is there any maximum or minimum of the y value? No, right? This graph can go as high as possible. It can go as low as possible. So there's no restriction on the range, right? So it's any real value. It's any real value. Fx is any real value, right? This is the symbol, right, you learn in math, right? Set notations, right? Set notation. This is belongs to, means that fx is a value that is real, right? This is real. Okay. It can means that, in other words, it can be any real number. Okay, it can be no restrictions, right? All right. So it's given that equation fx equals to have two solutions. You do not need to solve this equation. Use the pencil sketch the okay. Sketch this thing, so we know that the asymptote, right? The vertical asymptote, right? We know that the vertical asymptote would be x equals to 4/3, right? X equals to 4/3. So vertical asymptote. This is 4/3, and then this would be 3x minus 4. So let this to be 1, right? Because we know that ln 1 is what? Ln 1 is 0, right? When 3x minus 4 is 1, the entire thing is 0. Y equals 0 means the x-intercept, right? So let this solve this for x-intercept. So this would be 3x, 5x equals 5/3. 5/3, so 5/3, 1, 2, 3, 4, roughly here. Okay, 5/3. Maybe slightly close a little bit. 5/3. Okay, so yeah, it's a graph that keep going up, right? That has a vertical asymptote. Okay. Because of multiplying 2, it's quite steep, right? It's quite steep. Probably I need to make it steeper. Okay. Now this is a graph of y equals fx. Then how about y equals to f inverse, right? F inverse. Okay. F inverse, it would be the reflections in the lines, right? Reflection in the lines y equals to x. Okay, in the line y equals to x. Okay, so reflection in this one, after reflection, vertical asymptote becomes horizontal asymptote. Okay, becomes horizontal asymptote. And the vertical asymptote and horizontal asymptote should intersect as y equals to x, right? Okay, so this would be y equals to 4/3, and then the graph would be like this, reflections. Okay, seems good. Yes. You might be curious that why they tell you this thing, right? Have two solutions, right? This is just avoid your steepness is not enough, right? If your steepness is not enough, right? Because a lot of students they don't aware, right? They are not aware of the meaning of these two, right? These two, as I said, right? This is the vertical stretch. Vertical stretch will become, if original like this, vertical stretch double, right? It become like this, right? Double height. Okay. So but a lot of students didn't take notice of this thing. When they draw this graph, this kind of graph, right, they will draw under the line y equals to x. So when you reflection, it becomes like this, which is totally wrong. You get 0 mark for these kind of questions, right? So especially the question already gives you some hints, right? Has two solution means that they intersect at 2 points, right? Intersect at 2 points. 1 point is here, 1 point is further here, right? Okay. All right. So yes, it's given that gx equals to 2x minus 3 for x greater than equals to 3. Find expression for ggx. Okay, gx, right, it would be gx is 2x minus 3. So 2x minus 3, 2 times 2x minus 3 minus 3. So it's 4x minus 6 minus 3. So it's 4x minus 9. Looks easy. Okay. So yes, 4x minus 9. Okay. Then this thing is this, right? So f 4x minus 9 should equal to 4. F is what? F is this, 2 times ln 3. 2 times ln 3 times 4x minus 9. 3 minus 4. So minus 4. Equals to 4. So ln 12x, 3 minus 9 is negative 27. Negative 27 minus 4 is 12x minus 31 equals to 2, right? Equals to 2, yes. So it would be 12x minus 31 equals e to the power of 2. So x will equal to e to the power of 2 plus 31 divided by 12. Okay, should be exact form, so leave your answer in exact form. Okay, the diagram shows the part of the curve. Okay. And the straight lines. Find the area of the shaded region. So first of all, you need to find the x-coordinate of this intersection point. Right? What is this? Now we just solve simultaneous equations. You either substitute this into the y here, or substitute this into the y here. Doesn't matter, right? Okay, so we have 3 plus 4. I'm substituting this into the y here, right? The 2x plus 6. So we have 9 plus 12. 2x plus 1 equals to 2x plus 6. Okay, to get rid of the denominator, both side times 2x plus 1. Right, so you have 9 times 2x plus 1 is 18x plus 9 plus 12 equals to 4x squared. This is plus 6 plus 12x plus 2x plus 14x. Okay, so we have 4x squared plus 14x minus 18x is minus 4x, and 21 minus 15, 0. So 5 and 3, 2. Wait, can we factorize this thing? 5 and 3, 2 and 2. Yeah, can, right, we can do this. For this is 2x, 5, 3, minus 10 plus 6. Okay, so we have x equals to negative 3 over 2, or x equals to 5 over 2. So they have two intersections. Yeah, on the graph you only see one intersection because this is just part of the graph, right? The complete graph of this thing is actually something like there's a graph in the fourth, second and third quadrant. Okay, because this is just a transformational graph from 1 equals to x, right, from this graph. Okay, 1 over x is a graph like this. It's after transformation this graph become this part, right? So actually there are second intersections, but for the another part, the second part of this graph, but that part didn't wasn't drawn out, wasn't shown. Okay, so they show part of it. So we should use 5 over 2, right? Obviously we should use 5 over 2, the positive one. Okay, so find the area of the shaded region. So area of shaded region is the area under the curve from 0 to 5 over 2, right? Area under the curve means integrate, right? Integrate the curve 3 plus 4 2x plus 1 dx minus, right? Minus the area of this trapezium, right? Minus trapezium. So this trapezium, we need to know the height, right? A and B, and the height is 5 over 2. Okay, so this one is when y equals to 0. When y equals to 0, x equals to negative 3. Wait, is it? Not y equals to 0. This is x equals to 0. Make me a mistake. 2, 0, 6. So y equals to 2. Okay. X equals 0. So this is 2. And then when 5 over 2, what is the y, right? 3 times 3 y equals 2. 2 times 5 over 2 plus 6. So 3y equals to 11. Y equals to 11 over 3. So the height here is 11 over 3. Okay, so it would be, area of trapezium would be 1/2 times A plus B times height. Yeah, I guess that's all. Okay, so this would be integrate 3 is 3x, integrate this is 4, ln modulus 2x plus 1, but we need to divide it by the derivative of 2x plus 1, which is 2, so divided by 2, it becomes 2. Okay, so let's see. 5 over 2, 0 minus, what is this? This would be 12 over 6 plus 22 over 6. 12 plus 22, 34 over 6. 34 over 6. So 34 over 6. So this would be what? 34 times 5 divided by 2 divided by 2 divided by 6. This is 85 over 12. Okay. And then substitute 5 over 2 inside. 5 over 2 is 15 over 2 plus 5 over 2 is 2 ln 6 minus 0. Substitute 0 inside. 2 times 0 is 0. 0 plus 1 is 1 ln 1 is 0. Okay. So it's just like this. Therefore, are we required? Okay, in exact form. That's all, right? In exact form. So we have 12, right? This is times 6. 6 times 15, 90. So 5 plus 2 ln 6. Okay, I guess this would be the answer. Okay, the answer. Alright, number 10. The first 3 terms of an arithmetic progression, AP, right? It's an arithmetic. Arithmetic progressions means that we have a common difference, right? We have a common difference D, where x is not negative 1/2. This is just to make sure this is not a 0 sequence, right? Every term being 0. Show that the sum to n terms can be written in the form this thing, where a and b are certain. So as n, sum to n term with n divided by 2. We need to find out the d first, right? D would be second term minus the first term. So I have 4 apples minus 1 apples. I have 3 apples. Okay, so n minus 2 times 2 times the first term plus n minus 1 times the common difference. Plus n minus 1d, yeah. So n over 2, this would be 2 times 2x, 4x plus 2. Or I factor, no. The question is asking for 2x plus 1, so I should factorize the 2x plus 1 out. 2x plus 1, we have 2 plus 3n minus 3. Okay, and we have n over 2, 2x plus 1. Right, 2x plus 1. Okay, 3n minus 1. Okay, so yeah, a is 3, b is negative 1. Right, a is 3, b is negative. Okay, given that the sum to n term is also this, find the value of n. So n over 2, 2x plus 1, this is what we found in part 1, should equals to this one given in part 2. Since this is not 0, so we can cancel them, right? So what we have here is we have 3n squared minus n plus 108n plus 74. So 3n squared minus 109n minus 74 equals 0. So okay, let's see, this would be what? 74 and 3. 74 can be written as 37 and 2. 3 times 37 is 111 and 2, yeah, 109. Okay, so this would be 3 and 37 to negative plus. Now n is the number of terms which cannot be negative, right? So n equals to 37. Okay. Given also that the sum to n term in this part is equals to 1017.5. Okay, so 1017.5 should equals to find the value of x, right? So should be 54 times the n that we found just now plus 37 times 2x plus 1, right? Times 2x plus 1. Okay, so I guess just calculate, right? Oh, 54 37 plus, it should be 55 times 37, right? So 1017.5 divided by answer 1 over 2. So 1 over 2 equals to 2x plus 1. Then 2x would equals to minus 1 over 2x would equals to minus 1 over 4. Right, x equals to minus 1 over 4. Okay, so yeah, finally, we last stage. The first 3 terms of a geometric progressions, so we have a common ratio, which is the second term divided by the first term, so which is like this. Okay, and given that the n term is equals 4 times n plus 2 term, so for nth term to n plus 2 terms, it multiplied the common ratio 2 times, right? 2 times. multiply the ratio common 2 times. Means that r square, right? After you multiply 2 times, this is 1 over 4, right? R square equals to 1 over 4, okay? Right? You multiply the r 2 times now, but you are 4 times larger than after you multiply the r 2 times, right? After you multiply r times r squared, but you are 4 times larger than this thing. So which means that r squared should equals to 1 over 4, right? 1 over 4. Okay, so which means that r should equals to plus minus 1 over 2. Or let's see, so it's plus minus 1 over 2. Find the possible values of y. So when r equals to 1 over 2, right? So 1 over 2 equals to 3 times 2y plus 1. So 1 over 6 equals to 2y plus 1. 2y equals to negative 5 over 6. Y equals to negative 12 over 6. Negative 12 over... Wait. Negative 5 over 12. 5 over 12. So when r is negative 1 over 2, right, so it's negative 1 over 6, 2y plus 1, so 2y equals to negative 7 over 6, so y equals to negative 7 over 12. So negative 5 over 12, negative 5 over 12, negative 7 over 12. Okay. Alright. The first 3 terms of a different geometric progressions are sine 2 sine cube geometric. Find the value of theta for which has sum to infinity. So some of you has some requirements on the r, right? So let's work out the r first on the common ratio. So we have 2 sine squared theta. Okay. Now, in order for the r, right, to less than 1, okay, modulus r less than 1. So which means that modulus 2 sine squared theta less than 1. Okay, so means that sine squared theta less than 1 over 2. The square can take out of modulus, doesn't matter, right? Because both square and modulus, they have the effect of converting negative to positive. Doesn't matter. Sine theta, right? Square, okay. Square, okay, and 1 over 2. So sine theta modulus equals to square root, right? Square root of 1 over square root 2, right? 1 over square root 2. Okay, so which means that my sine theta need to less than 1 over square root 2, greater than negative 1 over square root 2. So my theta sine functions is sine function now for 0 to pi over 2. For 0 to pi over 2 means sine minimum is 0, right? Sine minimum is 0. And sine function is increasing function, so yeah. So just sine inverse both sides, right? Remain unchanged. So theta would be, this is pi over 4, right? 0 to pi over 4, right? 0 to pi over 4. Yeah, 0 to pi over 4. Okay. Alright, so that's all for this paper, right? See you next time.